Okay, so because the quiz was such a disaster for many, I'm going to kind of re-go over some things. That way you can fix some of the mistakes you made. So first I want to start off with transformations. And I think what threw everybody for a loop is that they said f of x was equal to something. I'm just going to make the example x squared minus 1. What I'm saying is, for what we're trying to learn, who cares what this function is? Who cares? It could be anything. It could be x to the 8th power, for all we care. We don't care. The quiz, it was asking what each of these transformations mean when I, let's say, have something, so some new function, maybe g of x, let's say that is taking 1/2 of f of x. So it doesn't matter what this is. It doesn't matter. I'm not asking you to write what that function would look like. I'm not asking you to say, to make this 1/2 multiplied by the function of f of x. I'm not asking that. I'm just asking, what, to get to g of x, what are we doing to the f of x graph? Well, we're taking 1/2 and multiplying it, and that is a compression by 1/2. That's all you had to do. Tell me that multiplying some a value in front of your function is either going to stretch it if it's a whole number or compress it if it's a fraction between 0 and 1. And so we had a lot of problems with that. So let's say that I have some new function, h of x, and it's equal to, I don't know, negative f of x. Again, who cares what f of x mean, or what f of x equals? We are just going to have that negative out in front, which means we're reflecting over the x. That's all you had to put. Let's say r of x is, I don't know, f of x plus 2. Again, don't care what f of x is. We just know that whatever that f of x graph is, we're going to move it left 2. Remember, whatever's in here is opposite. So, because it's positive 2, we're moving it to the left 2. And then lastly, let's say that we have something like, I don't know, j of x equals f of x plus 5. Again, we don't care what f of x looks like. We're just going to move that graph up 5. And when we move things, that's called a translation. This one being horizontal, this one being vertical. That's all you had to do. So, who cares what f of x is? We just know that we're going to take that and do things to it. So that was the first thing on the quiz that needed some addressing. The next thing is, when I have something in vertex form, let's say this, you cannot do negative b over 2a, plug it in. You can only do that when it's in standard form, ax squared plus bx plus c. Not when it's in vertex form, y equals a x minus h squared plus k. And so I had a lot of people on the quiz try to do negative b over 2a when something was in vertex form. Vertex form makes it nice. It's really easy to see the vertex is negative 1, negative 2. Because remember, inside the parentheses is opposite, outside the parentheses not opposite. And so from the vertex you can find the axis of symmetry. It's just this value here. And in a vertical parabola, the axis of symmetry will be a vertical line, meaning x equals negative 1. Now, because it's a vertical parabola, and the a value in this case is positive, that means that it's going to be a minimum. You can see that this graph over here has a minimum. And that's quite simply this value right here. So our minimum is negative 2. And so our minimum is at negative 2. The smallest value on that graph is the vertex, which is negative 2. That's the lowest that graph will go. And then so lastly you had to do domain and range. Well, if you sketch your graph, you can see you can plug any x into this. We don't have any denominators or anything like that. Any x would plug into this function and spit out a y. So we know that's negative infinity to infinity, or all reals. Now the range is a little different. We can't have, if this is a minimum, right here, oops, if this is a minimum right here, that means we can't have any value lower than negative 2. So that means my minimum is negative 2. Now, the maximum, there is no maximum, meaning it can go on and on and on forever. So negative 2 to infinity, or y has to be greater than or equal to negative 2. Domain and range. Now, just so I can do an example of one that is in standard form, we'll do one more example. Let's say we have y equals negative x squared plus 2x plus 3. Now we can do negative b over 2a, comma, plug it in. And so, let's just do that real quick to find our vertex. Negative b over 2 times a, which is negative 1, gives me negative 2 over negative 2, which is positive 1. That is the axis of symmetry. The vertex is your axis of symmetry plugged in. So we got a negative 1 squared plus 2 times 1 plus 3. 1 squared is 1, it's negative. 2 times 1 is 2. Negative 1 plus 2 plus 3 is 4. So my vertex is 1, 4. Now, because this is negative, that means I'm going to have an upside down parabola, meaning I will have a maximum. So I don't have a minimum here, I have a maximum. And again, the highest up that graph goes is 4. And then we do domain and range. Again, I can plug any x in, so it's negative infinity to infinity, or all reals. And my range, well, now there is no minimum. You can see my graph goes on and on forever in the downward direction. No minimum, but it has a maximum of 4. So y has to be less than or equal to 4. The only other thing I want to show with this is let's actually graph it and let's write it in vertex form. So writing this in vertex form, you just take your vertex, y equals a x minus h squared plus k. This is the h value, that's the k value, so let's plug it in. Y equals a. Well, my a is negative 1, x minus 1 squared plus 4. That's vertex form. That's all you have to do. So I'm going to draw a loose interpretation of the graph. 1, 4 is my vertex. I know it crosses the y-intercept at 3 because of that 3 right there. So I'm going to go ahead and put a point there. And that's what my graph will look like. That's really all you had to do. So watch this video. Let me know if you still have questions.